You're listening to China Manufacturing Decoded from the Sofeast Group. Hi, welcome to episode 293 of the podcast. Adrian hosting, Paul Adams back with me. It's another British takeover. Paul Adams, who is our head of new product development and a self-confessed injection molding enthusiast.
That's a good way to put it. Hello, Adrian. Always a pleasure to be back with you, son.
Yes, thank you very much for joining me again. The reason to get you on is because in recent weeks, listeners who have heard the last few episodes will have noticed we've been focused on, well, injection molding, polymers, plastic parts, this kind of world of materials, processes, and products. And we mentioned in the last episode that we would get together and talk about different polymer processing methods, right? So injection molding is one of them, spoiler alert, but actually there are some key processing methods that you can talk about. And the importance of knowing about these is because they all do have, well, the polymer itself that you select, but also the method that you choose has quite an important effect on not just the shape and the cost of your product, but also just everything, mechanical properties, the finish, the dimensional accuracy, chemical resistance, all kinds of things. So actually the decision of which method you choose for your polymer product is quite an important one. And this is one that you would regularly help our customers to make.
Well, that's a pretty good introduction, Adrian. So, yes, you're right. So, generally, when people talking about plastics, they automatically think of injection molding, and that's it. Game over. Well, clearly, that's not the case. So, yeah, just to sort of to follow on, this is a pretty good trilogy, let's say, because we talked about tooling and the complexity of tooling in the first episode. Then we talked about the polymers. And I guess this is a pretty good sort of follow-on from that, is looking at the alternative or the other processing methodologies that go hand in hand with producing parts from plastics.
Yes. Yeah. So that you're right. They do sort of fit neatly together. You're absolutely right. Now, in the quick intro, I was talking a little bit about why the different process matters. Before we talk about the processes themselves, and we'll cover several, just talk to me a little bit about why it matters, the impact.
Well, it's depending on the shape of the geometry of the product itself. You physically cannot injection mold some components. Okay. And you definitely need an alternative process in order to produce different shapes, geometries, wall thicknesses, and the such like. So it's the final methodology that is selected, regardless of what the polymer is, that will dictate the shape. Or you can actually spin that around and put it on its head. The shape actually has to dictate what the methodology is used in order to produce it. And this will become very, very clear as we go through that. So, it's injection molding is the go-to. It is the one on the tip of your tongue, on the top of the head, whatever you want to call it. It's, everybody associates plastics with injection molding because probably it's one of the most widely and commonly used methods of producing mass production plastic parts in the world. Okay, simple as that.
Yeah.
However, like I said, and it will become clear as we move forward, injection mold process cannot be used in some applications. Okay, and this is why it's really important to understand what else is out there, what other processes are at your disposal with respect to producing various different parts and components. And that's really an understanding you need to grasp when you're designing a product.
Yeah, indeed. Important decision.
Don't-
Great. So the first one we've already mentioned, injection molding. Okay, everybody should be relatively familiar, but let's cover that one, and then we'll perhaps get into some of the ones that may be less familiar.
Yes, that's right. Well, yes, this is a good place to start. Injection molding, like I said, it is generally the go-to process for sort of producing mass production of plastic parts. When I'm talking about mass production, if you are producing thousands of units, this is obviously the go-to sort of process. But you need to make sure that the actual part can be produced via injection molding. Okay. But it's also sort of suitable for high complexity components. But the more complex the component, the more complexity is built into the injection mold tool. Now, this is something we talked about in a previous episode, which I mentioned earlier. You know, you would have sliders, you would have lifters, you would have. We've actually created a couple of tools recently with gearboxes in order to unscrew multiple screw caps within a single tool itself. So these things can get very, very complex the more complexity you actually design into the component itself.
Mm.
But injection molding as a process is fantastic when it comes to producing parts that need high strength or great surface finish. When I'm talking about surface finish, mirror finish, as well as high texture and complex surface finishes. You know, we can mold in a leather texture, for example, something like this. So from that point of view, it's really good. As long as the part can produce where the tool is open and shut, you know, with the caveat of the lifters and sliders and cores and everything like this moving in and out, then we're all good.
Mm.
The other aspect is with the injection molding, you always have what we call a gate, which generally leaves a witness mark, unless there's like hot runners and in tool degating technology is used. So that's something to take in consideration. You will also have witness marks where the ejector pins are pushing the part out of the tool itself. Okay,
Mm.
so all of these small little aspects have to come into play when you are looking at the design. Now, if you've got a two surface, in other words, the front side and the back side are both cosmetic. Now, maybe injection molding is not the actual process you need to be looking at. Maybe we need to be looking at something else,
Mm.
for example, because you will have the gate mark, you will have the ejector marks, you will have other imperfections on the surface as it comes out of the mold itself. Now, quickly, sort of looking at some of the do's and don'ts from a polymer point of view. This we covered this last week on what polymers are and how best to use them. But the typical ones there again are ABS, PC, polypropylene, nylons. Fantastic use in injection molding process. Some of the more technical polymers that are not as good when they're moving through this process or trying to get sort of parts out of the tool, we're looking at really high temperature peak grades. That's some of the polymers that are really sensitive to moisture, for example. We've got problematic polymers, is what I'm saying. So again, we really need to be looking at the suitability of the product that you're designing, as well as the polymer itself. Is it well suited to injection molding?
Mm.
Okay. So this is sort of something that I'm not going to go into a lot of detail because I could stand here and or sit here and go for an hour talking about this. But obviously we need to keep moving. But this is going to give you sort of the top level holistic overview of each of these processes. So I would still sit here and say, Adrian, that injection molding is fantastic, and it is.
Sure.
But that's not the only tool in the toolbox, let's say.
Right.
Um, some of the typical products, again, we talked about this last week: Lego bricks, phone cases, consumer electronic cases, and outer parts and housings and everything in between.
Yeah, the list is enormous. A lot of stuff is is injection molded, and the going into the weeds of the technicalities of which polymers are, suitable or unsuitable, that's absolutely a conversation that we need to have when you are developing your product. But as you rightly say, it's too detailed for right now. But you actually would need to go through these points with your manufacturer for sure.
Absolutely.
So on to the second one.
I want to talk about extrusion. Now, back in the day when I was doing a lot of extrusion, right, all of the extrusion that I was doing was aluminum, or should I say aluminium.
Ah, yes.
Um, but so when we're talking about extrusion, a lot of people will automatically migrate to thinking about aluminum extrusions, your window frames, stuff like this, is a typical example of what an extrusion looks like. However, now this is also a very, very typical process for processing polymers and plastics. So basically what we've got here is very similar, or exactly the same sort of process as extruding metal, but this time round we are looking at forcing polymers through the die that gives us a uniform shape. Okay, so this could be a certain profile. It could be a very, very typical extrusion part is your plastic pipes
Mm.
in your plant. Okay, so this is all done by extrusion, for your plastic parts, your pipes. Okay. So that is basically where we're looking at extrusion. So you think, oh, yeah, yeah, yeah. It's not just the window frames, it's all of the pipes around, all around my house that are produced from various different polymers that meet the criteria in order to make it, if it's carrying water, it needs to be food grade, it needs to be weatherproof. If it's carrying electrical cables, it needs to be fire retardant, more stiff, etc., etc. So each of these products has its own criteria that needs to be met by the raw or the base polymer itself. But can you imagine trying to injection mold miles and miles of tube? It just can't be done. And so
Mm.
again, same polymer, different process allows you to actually process or produce the part that you are looking to do. Right? So again, this is really important. Now, when it comes to performance, extrusion's really good if we're adding additives to make the polymer stiffer or more flexible and stuff like this. Because of the process, you tend to get the orientation of the crystalline polymers in a row. So therefore, they all aligned and everything sort of makes it a better mechanical property in certain orientations, let's say.
Mm.
Typical tubing or extruded polymers would come from low density polyethylene, high density polyethylene. PVC is obviously at the top of the list there,
Mm.
as well as some ABS and polycarbonates and such like. Um, so that's basically where we are coming from an extrusion point of view. Now, there's there's one I'm going to throw in as a bonus at the end, but I'm just going to leave it on the table for the moment. Is a very fine filament that can
Mm.
be used in another process.
Mm.
Okay, so just remember that one. So a very fine filament that we're actually extruding that can be used in another one of these processes that we're going to talk about later.
Okay, great. I'll keep a note. Brilliant. So, yeah, extrusion, we've covered that. The third one, blow molding.
Yeah. I do like blow molding, to be fair, and this is one of those processes that generally you think, oh, how does that work now? But it's very similar to, well, it's a hybrid really of an injection mold machine with an add-on, let's say. So basically, what's doing is we'll get it's called a parison, okay, which is it's a molten sleeve of polymer that is like tube-like. Okay, it's a hollow tube. This generally comes in just drop down into the tool vertically. The tool would then close. Okay, so this is where we've got the similarity with the injection mold tool. We've got the core and cavity. Okay, they'll close around the person, i.e., the hollow tube. Okay, and then from there, we will inflate that molten polymer,
Mm.
or it's a semi crystallized, semi molten sort of piece of plastic comes in,
Mhm.
and then that expands into the core and cavity. We then go through a cooling process. The tools then open, and then you have your blow molded part. Now, I bet if you look around your house, right, you will have a blow molded part within 10 feet of you. And this is
Mm.
basically your water bottle, right? What you buy your fizzy drinks in, what you buy your whatever is in. All of these water bottles that millions and millions and millions of these are produced on a daily basis are all produced by blow molding. Okay. But it's not just the bottle itself. Can you imagine a bath or something like this, or one of the big water barrels? I can remember going, I've got one in my garden actually now, where I collect the rainwater and you water your tomato plants, for
Yeah, yeah,
example. A
yeah, yeah.
big yeah, it's all blow molding.
Oh wow,
Um,
the tools for those must be huge then, sort of as big as a
it is, yeah. Like I say,
Okay.
yeah. So these machines are like, wow. This is pretty good. Now we have just taken delivery of a 650-ton machine, injection mold machine in our facility. But some of these blow molding machines make that look like a toy. You
Yeah.
know, some of these things are massive. They really are. But generally, let's think about all of the bottles you've got around the house. That is your typical blow molded product.
So
Okay.
is that why when you get these bottles or maybe tubs or containers and things like that, oftentimes on the bottom of it you can see kind of like a little like a nipple that's left over, and is that where they've sort of closed it off and then cut it away from
E-
whatever's wasted, and that's the remainder of the process?
Exactly. Yeah, you've got it. You've got it. As it comes down, right, it needs to be closed, otherwise it'll be an open hollow tube.
Yeah.
Okay, so bottom, it's sort of crimped
Mm.
where they cut the length from the previous one. So as it comes through, you crop it, and it's that cropping action which closes the bottom. As it's then dropped in, it will crimp again, but you got to make sure that you got the air or the gas that's going into the open section into the to the top of the sort of the neck of the bottle.
Hmm.
But with that crimping action, you've already closed the next section that's coming through.
Mm. Okay.
So which is good. But yeah, it's and again the blow molding is really good for polycarbonates, like I say, high density, low density polyethylenes, clear, see through sort of products, and it's very good for thin wall but uniform walls.
Okay.
Okay, which is really good. So yeah, blow molding. If you ever get the chance to see a blow molding machine, go and have a look at it. It's like a wow factor.
Interesting. Next time I'm in China, we'll go and find one locally,
Yes,
unless
let's
we're
do it.
doing it in our facility for some reason, and we can go and marvel at this. I'm surprised how many common products are probably actually blow molded then. But yeah, that's a new one for me. Just as a quick aside, the speed of these, because one of the things that we love about injection molding is that you can create at scale quickly, right? In terms of extrusion and blow molding, are these also very quick processes to make a lot, or
Oh, extruding is mind-blowingly quick.
okay?
Yeah, it's an extremely quick sort of process because you can force the polymer through the die or a series of dies very rapidly, and it cools up the other end sort of quickly, so it becomes a very stable product as the process is moving. So within the series of dies generally have a series of dies. The final one is the final shape. The first one is pre-forming.
Yeah.
A series in between, so I can get it to the right size and diameters, such like. but after that, it's just within a meter. It's cool enough in order to become a stable product. These, they shoot down the end of the factory at such a speed. It's unbelievable.
Interesting.
Again, it's a fantastic sort of process to go and watch if you ever do get the chance. Blow molding, it's not as quick as some of the injection molding sort of processes, but again, depending on what size of bottle or product, let's say, you are producing. Here's another interesting one. You're a bit of a football fan, I know you are. So Adrian,
I am,
uh,
yeah.
yeah, if you go down there, if you're lucky enough to get I believe they're all seating stadiums these days.
Yes.
The seat that you'll be sitting on will
Mhm.
probably be blow molded.
Interesting.
Now,
Okay.
so things. So yeah, blow molding, very good. And again, it's like I'm not just a fanatic about injection molding. It's like anything that's like processing polymers. Like I'm in. Yeah,
Yeah,
sign me up.
and all of these processes so far are using a tool and basically finding different ways to get the polymer onto, into, or through the tool to produce the part that you're after. And I think that's the key, isn't it? Injection is just one of the processes that you've mentioned. So, yes,
It is.
um,
Yeah.
for thermoforming.
Yes, thermoforming. Let's have a look at that. You think, what the hell is that all about? Well, it's a plastic sheet, okay, and you warm up the sheet of sort of polymer, is stretched, and then is put over a mold or a shape, let's say,
Mm,
call it the mold, but this is a male mold. Okay. So you would stretch that heated sheet over that mold, push it down to the flat, and generally you would then suck that polymer down with a vacuum,
mm,
forming a final product shape.
right. Okay.
So basically, if you've got a piece of cling film, right, you can do this experiment at home. You've got a piece of cling film, you put that on a paper cup, okay, turn it upside down. If you put a hole in the bottom of that cup and you put a straw in there, if you suck it, that polythene or the cling wrap or whatever it is will basically be drawn into the top of the cup. Okay. So basically, that's how the vacuum works. It's drawing down that soft, pliable sheet of polymer over the form, right? And as it cools down, and again, this is a relatively quick process, not yet relatively quick, let's say, and it will basically take that final form, okay, and then you'll release the vacuum, boom, and it will pop off
Mm,
that male form. So, which is good. With respect to accuracy, thickness, there are variabilities. Does it warp? Does it maintain its real high tolerances? No. Yes, it does warp, but no, it doesn't actually hold its tolerances as well as some of the other processes, let's
mm,
say. So it's definitely got its limitations. However, when you look at the typical product, you'll think, yeah, all right, it doesn't really matter. Yeah, I'm talking about the clamshells that you buy your sandwiches in, or you get your ice cream in, or you get your produce in at the supermarket. So does it really matter if it's slightly warped or slightly out of tolerance? No, it doesn't really,
mm,
because it's not meant to be a high tolerance product or a process in order to get the high engineering levels that some of the other processes do offer. So, it's a thermoforming definitely has its place. And again, it's right up there with respect to volume per part, per ton, per day. It's right up there. So how many clamshells do you go around or packaging, see-through packaging, do you see in the supermarket shelves?
oh yeah,
An
millions.
awful lot.
Yeah,
An
yeah.
awful lot. Yeah. So, it's these day-to-day things that you don't realize. You think, "Hmm, if you see," I'm terrible when I walk around the supermarkets. I'm often thinking, "Well, how's that made?" Like, this is from the supermarket, you know? Well, I'll pick up the sandwiches. I won't necessarily look at the sandwich. I'll look at the packaging and say, "How is that made?" So, which is a dangerous slippery slope to go down, but something something I enjoy anyway.
Sure.
Um, so yeah, it's basically a very very easy process for high volumes in a not necessarily high tolerance requirement environment. Okay,
Okay.
some of the typical polymers that are used in this process again is polycarbonate, polypropylene, PVC, PET, some of these common sort of food grade products as well, simply because yeah, there's a lot of packaging done with this methodology. And
Yep.
again, it's not just about food packaging. If you go get yourself down to the local hardware store and you'll find yourself a pair of whatever it is inside of uh, a hard plastic see-through shell, guess what?
Yep.
Thermoforming.
Yeah, like a pack of nails or screws or something.
Yeah, yeah, exactly. You got it. You
Absolutely.
got it.
Okay.
So,
Yep. Yep.
so it's so but it's not just that. You can do bathtubs as well. So it's the big stuff
Oh, wow.
can actually be used. Refrigerator liners is another one. I just throw that in there for fun.
Interesting. That's a big mold for those then. Good. Um,
Yes, yes, it can be. Yeah,
the fifth that we're talking about, rotational molding, or the better name, rotor molding. Now,
yeah,
when
rotor molding. Yeah.
when I first learnt about this, never did I realize that you could actually produce a type of polymer part in the same way that you'd roast a Christmas goose.
Well, in a rotisserie, but this is more like a reverse rotisserie. You
Mm,
know what I mean? It's yeah, this is a pretty cool one as well, and it's somewhat different to the rest of them. In previously, we've been talking about I don't know, injection molding. You were actually putting in pellets. The polymer comes in a pellet format that goes into the dryer. From the dryer, it goes in the hopper, gets processed through the screw, and then squirts into the sort of the open cavity of the closed mold. Here, we're sort of basically throwing in your pellets into, let's call it a cement mixer, all right, for lack of a better term. Okay. But that cement mixer is the core or the shape of the actual product itself.
mm,
All right. What we're doing here is we're rotating that, and it rotates and rotates. It's obviously a closed drum, and you rotate everything, and it's basically heating up. And as it's rotating, the polymer that you put in melts. It then centrifugally goes to the outside of that mold itself.
mm.
Okay. And basically we're getting the shape of the internal mold itself.
Nice.
Okay? So that's one way to think about it. It's then cooled, it's then cracked open, and you've got your product from that. Now, generally, this is used for larger products. When I'm talking about larger products, you're talking about playground equipment, sort of slides, and uh, you can have road cones. You could have the kayaks and various different sort of larger products from that process itself.
Mm,
Now, some of the key performances that we're looking at here is it is possible to get the uniform wall thickness because of the process itself. The cooling rate does affect the crystallinity,
mhm.
sorry, and therefore the impact strength, and it's not necessarily uniform throughout the whole product itself. So
Mm,
again, we need to be careful with respect to what the process is capable of producing versus what the part is required from a performance point of view.
mhm.
Right. So we've looked at all of these different processes. Now you think, now do I go with my traffic cone? Now do I go rotor molding, or do I go blow molding, or do I do thermoforming? Well, probably all three are capable of producing that type of product. So you've got to look at the volumes. You've then got to look at the cost of the polymer and the cost of the processing. Also, the quantity. In other words, the sort of the capability of the process itself can actually produce the quantity you need in the time you need it.
Yes.
Right? So, and again, that is all cost driven.
Right.
So, what sort of courses? Make sure you're looking at the end product requirements, specification, look at the polymer, and then the process, or the process and the polymer go hand in hand.
Yeah, and I mean your manufacturer should be advising you on the options. If a certain type of polymer is more cost effective for you and will do the job that you need it to do, but you need to use a different process to create the product, then this is a conversation that you're going to have, for example.
Correct.
Yeah.
Yes, that's right.
Okay.
Yeah.
So before we wrap up, I think, is it time to remind you about the filament?
Oh, yes, yes, yes. You're right. The filament. So we talked about extrusion.
Mm,
Okay. And the extrusion is you are a very, very similar process at the start where you are, from an injection mold point of view, you are putting your pellets into the dryer, into the hopper, into the processor. Now, this time it's not going into the injection mold machine, it's going
mm,
into something similar, but it's extruded. In other words, it's pushed through a set of dies in order to get the final product. Now, I was at an exhibition a couple of weeks ago and they were showing this. I think, oh, look at that! Look, this is cool. This is extrusion on a mini scale. And what they were doing is they were producing filaments that can be used on a typical 3D printing
mm,
FDM machine.
interesting.
Okay, so which is a fused deposition machine. Okay, and you can actually produce these filaments in all different types of polymers, which is great for 3D printing in that particular sort of environment. Now, when we're talking about additive materials, we're talking, in this case, the filament that is produced from your extrusion, which is a previous process, can then be used in a secondary process, which is FDM. Now, this melts, it lays down a layer of polymer, which is the molten extrusion goes through a process and it lays down, and then it continuously builds up layer after layer after layer until you've got your 3D printed product in the polymer that you are intending to test.
Mm,
Now, I got these today, very, very quick. I said to the guys, I need this urgently. Within an hour, I had the parts back on my desk in ABS.
mm,
Okay. Now, the material was exactly the same as what we're going to be using in production. However, the process is not the same as injection molding. Therefore, the mechanical properties are not exactly the same as what I would get in an injection molding part. And the surface finish is a lot rougher simply because you're laying down multiple layers on top of each other in order to form that final product or get that final product shape. But it's fascinating that one process can produce a part that can be used in a secondary process within this whole process that we're talking about. It's
mm.
really process, yeah. So that was good. So yeah, I was using sort of testing out a modification that we needed on a component in ABS today, and it works, and I validated the change, and we can now go forward and put those changes forward into the tooling. So very, very worthwhile doing.
Mm, that's great. And I like the crossover between producing plastics or polymer parts in large quantities and actually being able to produce the extruded materials that you need for the 3D printing, which actually you're probably more likely going to be using for prototyping in small amounts.
Yeah, I know, right? It's cool. It's cool. You come around in the full cycle.
Absolutely. Yeah, exactly. It all comes back to the polymer again. So for the listeners, I mean that's sort of six different processes if we count the 3D printing that we've gone through. I wonder which of them surprise you or which you're currently using. I think the blow molding, that seems to be creating a lot of very ubiquitous products for me. But honestly, having gone through them now, I think that we're all aware of products in and around us made through all of these processes. What I want to know is who actually came up with the processes initially. Like, it's like, right, I've got my polymer. Now, how do I form it into different shapes or different parts? That's some ingenious stuff right there.
Yes, indeed. I haven't got any names for you, but
No.
I would like to shake their hand.
Absolutely. Right. So, yeah, these are the sorts of important conversations that you're having with customers, but hopefully going through these has shed a bit of light for the types of processes that everybody listening might come across when creating their plastic parts or components and so on. Great. Let's call it a day there, Paul. Thank you very much. That was
Okay.
the third of a trilogy about different polymer related episodes. I think we do have more to discuss with relation to this topic in the future. And when we do, we'll definitely get you back on for that.
Awesome. Look forward to it.
Thanks again for listening to this podcast brought to you by the Sofeast Group. We're on a mission to provide you with everything you need to manufacture effectively in Asia, including inspections, auditing, new product development support, contract manufacturing, 3PL warehousing and fulfillment, and much more across Asia's key manufacturing areas. Visit us at sofeast.com, that's SOFEAST.com, to learn more and get help. If you've enjoyed the podcast today, please do rate, review and share because it will really help others discover us too.